So can you tell me what the first one represents?
Resistor.
Okay, resistor. And the second one?
A light bulb.
Okay, light bulb. And for the third one,
Voltage.
um, so usually you can say voltage, but they call it a voltmeter.
Oh yeah, sorry.
Yeah, so it does read the voltage, but it's a voltmeter. And this
Okay.
one,
Ammeter.
yeah, I'm not sure about this spelling, but
Double in.
sorry.
Double in.
Okay, sorry, thank you. And this is
A battery.
a battery or cell, yeah. Uh, uh, yeah, let's just say battery. So at least we know that you are familiar with these things. And now the other thing we must focus on is how these things are connected in a circuit and how they are connected and can be connected in a circuit. So more specifically, these ones. So okay, let me just go a bit back before we talk about how they are connected. Um, Let me just erase this part. So when it comes to a circuit, we have two types of connections. Um, we're gonna have our series connection and our parallel connection. So when something is connected in series, that just means like that when the wire goes there, it's gonna be here, that thing, and then basically it's on the same piece of wire. So this is in series, and then we have a parallel connection, which is gonna be something along the lines of this. So it's as you can see in series, it's on the same wire, but when they're parallel, it's not on the same wire. Every everyone has their own individual wire, but obviously those wires are gonna end up interconnecting because it's a circuit. It has to form a circle of electricity. So this is your parallel connection. Uh, so this is gonna be your parallel connection, and this is our series connection. And now we're gonna come back to the components of the circuit that we personally are gonna focus on. We're gonna look at our resistors and light bulbs. Basically, I don't think it's necessary for me to include light bulbs because light bulbs have a resistance. At the end of the day, light bulbs at this phase are gonna act as resistors because we're gonna be talking about in a system where we don't like include like the energy loss and all that stuff. So light bulbs are basically resistors. So I'm gonna rub them out. So we're gonna look at our resistors. So resistors can actually be connected in both manners. They can be connected in parallel, or sorry, in series, and they can also be connected in parallel, right? And then when we look at resistors, we're gonna look at them like in the different ways they are connected. And then now we're gonna go to our voltmeter. Our voltmeter is only connected in parallel. It is never connected in series. It is only connected in parallel. And this is due to the high resistance of the voltmeter. If you connect your voltmeter in series, then most likely your circuit won't work because the voltmeter has such a high resistance. So usually when you connect something in parallel, it ends up having a lower resistance than when it's connected in series. Uh, yeah. And then now we're gonna go back to our ammeter. And the ammeter is gonna be connected in series only. So resistors are connected both in parallel and in series. The voltmeter only in parallel and the ammeter only in series. So just keep that in mind as we're gonna go forward. And now the battery, like the battery, you are always gonna see batteries connected in series, and you'll rarely ever see them connected like this. They never, like when they're testing you guys, you'll rarely ever see batteries connected in parallel. They're always gonna be connected in series most of the time. Yes. So we're gonna move forward, and we're gonna go to the driving. What can I say? The driving topic of uh of this. So let me just rub these out. So I'm gonna give you some general equations that you will use given when you are given different connections or different connections of resistors, because obviously you know that the voltmeter is connected in one way, the ammeter is connected in one way, so there is no difference. The cell is usually connected in one way, so it doesn't make an impact on the circuit. But when it comes to the resistor, it can be connected in different ways. So those different connections have different effects on the overall um, quantities of the circuit. So first we're gonna start with resistors that are connected in series. So we're gonna have something like this and something like this. So when you have resistors connected like this, let's call this R1, this R2, and this R3. So the total resistance of a circuit, given that resistors are connected in series, the total resistance, and you can denote or the symbol for this total resistance for resistors in series, you write it as Rs. And this total resistance is equal to R1 plus R2 plus, it goes on and on and on, depending on how many resistors you have in series on your given circuit. So you can have like 10 resistors in series, R1, R2, R3, all the way up to R10. So that's why I'm just gonna say dot dot dot. It goes on and on.
Excuse me?
Sorry.
I just wanted to make sure. So if it was in parallel, would it be 1 over R1 plus 1 over R2?
Exactly. That's what I was gonna move into next, but at least like you
Sorry.
get the gist of the idea. So that's basically it. And then now we're gonna go to the ones that are in parallel. But thank you for pointing that out. Like it, it's very reassuring when like you know that this person knows what you're doing, you know. So obviously resistors in parallel, it's usually gonna be something along these lines. Uh, Forgive me for my bad sketches, but it is what it is. So we're gonna end up with a situation like this when we're talking about resistors in parallel, and we're gonna have this, as you said, it's gonna be 1 over R1 plus 1 over R2 plus you go all the way to how many resistors you have that are in parallel. So, oh yeah, sorry. This is also 1 over RP. So it's 1 over RP is equal to 1 over R1 is plus 1 over R2. So there's this, and there's also this special, I don't even think it's special, but it's just through mathematics. If you only have two resistors that are in parallel, you don't have to go this far. You can actually just say resistors in parallel is equal to R1 multiplied by R2 divided by R1 plus R2. So this formula only applies if there are only two resistors in parallel. Only if only if there are two resistors in parallel. So if you have two resistors in sorry.
I wanted to ask a question.
Yeah, you can ask. You can ask.
So, like, if I do this, the second equation for this, when I'm done with this answer, then do I add R3, or can't I use this at all?
No, you can't use this at all. This only works
Oh.
with two resistors in parallel because you're not gonna get the value of 1 over RP. You're actually getting the value of RP directly. So if you have a third one, you're gonna have to go back to the above equation. But thank you. That was actually a good question. So this is all that you might you'll need to know about the resistors, and your overall total. You can say R total of the given circuit is going to be equal to Rs plus Rp. Not Rs plus 1 over Rp, Rs plus Rp. So this is the main equation. If you have a circuit and it consists of some resistors that are in series and some resistors that are in parallel, you're gonna use R total is equal to the sum of resistance in series plus the sum of resistance in parallel. So I think that's mostly it for this section. I think we can move on. So, oh, sorry, were you writing it down? Because I think yeah, I am recording, so there's no
I
need for
wrote
you
it
to write it
down.
down. Sorry?
I wrote it down.
Okay, so I can erase.
Yes.
Okay. And then did you guys go through Ohm's law as well?
Yes.
Okay, okay. So we can go to Ohm's law now. So I'm just gonna give you the concept, or wait, let me just try to uh, yeah, let's try to do a question on that first. So let me just open up a question paper for you quickly. Uh, uh, mm, mm, can you see the question paper?
Yes.
Okay. Mm, yeah, yeah, yeah. So I'm just gonna show you an example, and we're gonna do question 11.1.2. Let me just open this separately, and I'll open this other one. Uh, what can I use? WordPad. Okay, so we have we have the diagram as it is given to us. And they say the switch S is open And when they tell us the switch is open, oh, I also forgot to tell you about the switch, but I'm pretty sure the switch is not that complex of an operator, because when it's open, that means there's no electricity flowing through, and when it's closed, that means there is electricity flowing through the circuit. So when they say the switch S is open and they want you to write down the voltmeter reading, what you know is that even though electricity is not going past here, it's not gonna go in this direction. It's not going past here because the switch is open. It is still going up there, up to the voltmeter and back down to the battery. So basically the electricity is just gonna go in this small circle. And since they gave you the rating of the battery, which is 24 volts, when they see write down the reading on voltmeter one, it's just gonna be 24 volts, because um, none of the current has been is being transferred to the external circuit, which is this part. This part is going to be our external circuit. And they want you to see the reading on emitter one. So, that's going to be 0 amperes, because there is no current flowing through the circuit at the moment. And now they say calculate the equivalent resistance of the circuit. When they say calculate the equivalent resistance, they basically mean calculate the total resistance. So when they say R equivalent, REQ is basically the same as R total. And then that means we have to use these resistors and determine, firstly, we have to determine how they are connected with respect to each other. And then after that, we can determine what we have to calculate. So if you can see, these two resistors here are connected in parallel, and this one is connected in series. So that means we already know that our R total is equal to the resistance in series plus the resistance in parallel. And our resistance in series, since there's only one resistor, it's going to be 8 ohms. And now we're going to have to find our resistance in parallel, because there's actually two. So since we know that equation where we have two resistors, our P is going to be equal to 8 multiplied by 8 divided by 8 plus 8. So I'm pretty sure you know this equation. And then we're gonna do, yeah, sorry. Um, where's my calculator? Uh, so give me a second to find it, because my stuff My room is a mess, but anyway, um, let me just say 64 divided by 16. That's gonna give me 4. So our resistance in parallel is 4. And our equivalent resistance is 12 ohms. So I just wanted us to do this question specifically. Sorry, can I take this call real quick?
Yes.
Thank you. Yeah, sorry about that, but um, can you hear me?
Yes.
Okay, because I'm just checking here, it doesn't show anything. So basically, that's how we're gonna use these things. And let me just try to go to the other question paper and find a similar question. Uh, and then after that, we're gonna go into Ohm's law. Honestly, most of these things, they're easy when someone is describing them to you, but you have to actually go through the work. So I'll try to send you a question paper or two if I can. So let me just do this. So now this one is much more based on Ohm's law. So let's just end the meeting here, come back for the next section, and then I'll help you with Ohm's law. Is that fine? Because it's gonna end soon.
Yes,
So
I'm having two lessons.
okay. Okay, see you now. See you now.
Are we having two lessons?
No, it's just that um I'm using
The
like the
time is
limited version of Zoom, and I don't want it to cut us off
okay.
abruptly, and then.
Hmm.